The brain is still, to this day, the most powerful machine learning entity that we know. It is bigger than any language model that we have created, and it works at a power budget that would make NVIDIA, Cisco, all these companies jealous. I mean, it is just a fraction of the power that these language models need to operate at. So really the power comes in connecting the neurons together to make this wonderful thing called the brain. And so with neural networks, the analogy holds.
Hello and welcome to the Cisco Learning Network podcast. Today on the show, we're talking about generative artificial intelligence, what it is, why it's special, and how it can be used from a network operations perspective. We're lucky to be joined by Guarav Khanna, a solutions engineer leader at Cisco who breaks down everything you need to know about AI, how it started, where it's headed, the terms associated with this emerging technology, and how you can start learning more.
Wonderful to be here today. My name is Guarav Khanna. I am a SE manager in Commercial West, Gold Rush Select to be specific. I've been at Cisco 23 years, almost all that time in sales. In my previous role, I was a data scientist, and I really enjoyed that role, building models, working on traditional AI. And then when ChatGPT came out, we pivoted to working on generative AI and building Q&A systems and intelligent routing systems and so on and so forth. So it's been a really great journey to watch this field just actually explode in popularity, and it's been just wonderful to be part of it. So November 30th, 2022, I think will go down as one of the most pivotal events, not just in AI, but in technology, because it was our introduction to ChatGPT. And it was interesting. It wasn't really launched with a lot of fanfare. OpenAI put it out there, and there was a simple tweet by Sam Altman saying, "Hey, come check us out."
The tweet from Sam Altman read, quote, "Today we launched ChatGPT. Try talking with it here," as well as a link to ChatGPT version 3.5.
Now, journalists and others had been aware that there was this technology out there. It was being reported on that these generative AI systems are there. We had experimented with a few of them. But when ChatGPT was released, what they did, which was really pivotal, was they took a much more advanced version of this generative AI system they were working on called GPT, and they married it with a chat interface. So they made it very easy to access this technology, and that's why it went viral so quickly, is because people hadn't really seen the ability to generate language like that. I mean, our information retrieval up to that point had really been Google that had dominated sort of our consciousness, if not our search workflow, for a generation. And so it was really remarkable, and it was new, and people took onto it, obviously, in a big way, which is why it went global so fast.
ChatGPT acquired 1 million users just 5 days after launching in November 2022. For context, Instagram reached 1 million users after 2.5 months, and it took Netflix 3.5 years to reach 1 million users. And it's estimated that ChatGPT hit 100 million monthly active users in January 2023. This kind of growth in users is unprecedented.
So ChatGPT and GPTs in general and text-based generative AI in general, of which ChatGPT is probably the most famous example and the one probably people are most familiar with. All of them have one thing in common, and that is that they're amazing at generating text. Now, what they can do is based on a prompt, they figure out what words come next, one at a time. That's the remarkable thing. But the other remarkable thing is that they're aware at all times of context. So they're aware of the prompt that you put in and what they've already generated. And that's why they can create very coherent sentences, paragraphs, essays, what have you. That is really key in that it's able to really generate wonderful text. Now, it's important to understand these were not built to be machines that gave you accurate information necessarily. The fact that they output accurate information is because they've been trained on information where the sequence of words forms sentences which are accurate. But they can also generate fiction. Fiction is not accurate, it's just fiction. But when you ask it a question, a lot of times it gets the answer correct, but it's not guaranteed to get the answer correct. And so that's a very important thing. So they both have this incredible sort of potential to give you great information in very eloquent language, but they don't always get things right. Now, one of the other things that I think is really important is that they can take on the role of a persona. For example, you can say, look, explain me a mathematical concept in a way that an eighth grader would understand. In fact, that's one of my favorite examples. You know, an example I show in a lot of my talks is explain me this concept of covariance as if I'm an eighth grader. And it's just beautiful, the examples it comes up with. It says, imagine you and your friend are throwing a ball in the air. You know, you throw a ball in the air, your friend throws a ball in the air. If they go about the same height, the covariance is 1. If you throw a ball in the air very high and your friend throws it very low in the air, that is a lower covariance. And if you throw it in the air and your friend throws it on the ground, that's a negative covariance. Well, what was I doing in 8th grade? I was playing football and baseball. So of course I would understand that analogy. And in a way, these things can be tutors and very intuitive tutors that is just remarkable. So their potential to train us, but train us at a level that we want, is really actually one of my favorite use cases. I think it's almost underused, to be honest. You know, when I tell people about it, they're very surprised that it can do that. And I just really hope this is one thing a lot of people take advantage of.
Before we get into what this technology is capable of and the fundamentals of how it works, Gaurav takes some time to break down some of the terms that come up when we're discussing any kind of artificially intelligent technology, especially algorithms and models.
So there are a lot of terms thrown about, and I will tell you, even data scientists, people who are good friends of mine that have been working in this field before anybody could spell AI, even they start to conflate terms. So let me just step back, and I'll be a little bit academic for a second, but it's important to keep some of this stuff straight. AI is very much an umbrella term, and AI means a lot of different things to different people, but essentially it means, can you put together predictions in a way that are meaningful and accurate? And whether that involves traditional techniques using numbers or whether that involves language, all of that is under artificial intelligence. Fundamentally, artificial intelligence is a way to predict things very intelligently. Now, you break that down, machine learning is a type of artificial intelligence. So if you ask people in the field, like for example, if you asked me a few years ago when I was in my data science role, hey, G, what do you do? I would say actually what I do on a day-to-day basis is called machine learning. And machine learning is this concept of taking algorithms and training them on data so that they can make predictions. That was machine learning. And so machine learning is actually what we did. Deep learning is a form of machine learning, and most of deep learning happens on these wonderful things called neural networks. And deep learning tends to be with neural networks that are very, very big. They have a lot of what we call perceptrons. They have a lot of nodes, and they're very big, and they're able to process things like language or huge amounts of data. So artificial intelligence, the umbrella term, machine learning, let's dig down and work with algorithms. Deep learning is using deep neural nets to achieve, again, the ability to predict things like language. Deep learning is actually what ChatGPT and other image generation models are based on. These tend to be very, very large neural networks, billions and billions of parameters. At the risk of sounding like Carl Sagan, these are billions and billions, sometimes trillions of parameters is where we're headed. And they're able to give us this wonderful ability that we are experiencing today. So even though AI has evolved a lot, and again, you know, there's in these fields that are moving so fast and are so innovative, things don't tend to stick around a lot. But one of my favorite quotes or definitions about machine learning comes from Professor Tom Mitchell. He is a computer science professor at Carnegie Mellon University. And in 1997, he offered the following definition. He said, a computer program is said to learn if its performance in a certain set of tasks, you can call those tasks T, if its performance in those tasks T, as measured by a set of metrics, let's call them P, improves with experience, E. Okay, so a set of tasks T, measured by some metrics that we call P, improves with experience, E. Notice he didn't say improves with time. What he was saying is these things are dynamic. If you train them better, if you give them better data, if you give them more accurate data, their performance on T improves as measured by P. And that was a really important definition. In fact, even in our Gen AI world, this definition holds true. And the reason why that's significant is because it was very different from the traditional computing paradigm. In the traditional computing paradigm, you created a program, you fed it input, and it gave you a deterministic output. What we're saying is these machines are actually not like that. What they do is you give them both the input and what the output should be, and they learn. And the better input and output you feed it, the better they're able to make predictions. So they improve with experience. That's really the key part of the phrase that I absolutely love about this definition. Improves with experience. Because again, it's very rare to have things that stand the test of time. This definition has held true very well. It has aged very well into our current era. As I mentioned, even data scientists kind of conflate these terms, and it's forgivable. But it is important to keep it straight because there is a difference, a very key difference between what a model is and what an algorithm is. So let's start with the algorithm. Because the algorithm is really that set of instructions. It's instructions A, B, C, D. I'm going to give you a bunch of data, and I want you to perform A, B, C, D on it. Okay? And a lot of times these algorithms have an iterative step. So you perform A, B, C, D, you get a result. You take that result, and then you perform A, B, C, D to do something else or to close a gap or to reduce an error or something like that. That's an algorithm. When the algorithm is done doing its thing, what is left and the result of all of that is what we call a model. So just to use GPT as an example, the algorithms that train GPT taught this thing how to understand the relationships between words. So a bunch of algorithms were running and they did their thing and they taught this model some things. Now, it wasn't always one algorithm. It could be a series of algorithms. You don't have to have just one algorithm and one model. You can have a series of algorithms work. So when a series of algorithms was done doing its thing, it created this thing called ChatGPT. So when you use ChatGPT, you're using a model, which is the completion of a bunch of algorithms working. So that's the distinction between the two. The algorithms run, do their thing. They give us this wonderful output. That output is the model that we use. Now, if we want to use a new model, we have to run those algorithms again on either a new set of data or improving upon an existing model. Both of those are possible. But that's the distinction between an algorithm and a model.
While AI is exploding right now, it has taken a lot to get to this point. There were many iterations in the evolution of AI across the span of many years. In fact, some of the technologies supporting generative AI programs like ChatGPT began with discoveries and scientific breakthroughs that began in the 1950s and 60s. So in order to understand AI, let's take a moment to understand its story from its humble beginnings and how it was birthed from humanity's own likeness and image.
AI has been a journey. Again, I say November 30th, 2022 as a pivotal day. But like any technology inflection point, and frankly, any great moment in history, when you study it, in school, you start to realize that, wow, there was so much that built up to having that moment, to making that moment possible. This is just not a story in technology. It's a story of our humanity. And AI is no different because it has been a journey. And so before anybody called it machine learning, there were techniques like regression and classification. And what they did was they took a lot of times numerical data and they were able to process it to give us predictions. So for example, you could predict, the prices of homes in a neighborhood if you had data on all the sales that happened in a neighborhood. You could do predictions like, hey, tell me who's going to be able to pay their credit card on time or not if you were a bank, and we're using all these techniques. They were eventually called machine learning, but people were using these even before that term was around. What happened as part of this journey is that, especially in the 2010s, there were a couple of things that were really, really important that happened. One was this was the era of big data. I was in Cisco when this happened. I saw it happen. Cloud companies came out, and there was an enormous amount of data being generated by enterprises, and something needed to be able to process them. And as it turns out, traditional programming techniques just were not up to the task. They simply couldn't handle that much data. So that was the first problem, was there was a lot of data and there was storage now to hold it. And then Moore's law, that famous law that talked about how much processing power improved, every 18 months and so forth, that was still going strong.
Gordon Moore was Intel's co-founder, and Moore's law is considered to be the golden rule of the semiconductor industry. It basically states that the number of transistors on an integrated circuit will double every 2 years with minimal rise in cost. He predicted a doubling of transistors every year for the next 10 years and published this theory in a paper released in 1965. Moore's law has been a guiding principle for the semiconductor industry for about 60 years now, and many have predicted the death of this theory, but according to Intel, quote, "With advanced packaging technology and new materials, the pace of Moore's law continues," end quote.
So the confluence of these two things and the creation of new algorithms like, clustering and neural networks and all of these things made a really great confluence to take machine learning up to another level, where it was not only processing huge amounts of data, but also huge amounts of text. That was a journey leading up to this wonderful moment in November 2022 when ChatGPT came out. It was actually building on a lot of innovations in machine learning techniques that were made possible not just by improvements in algorithms, but improvements in compute and storage. So a few of the greatest hits along the way of this journey. Regression is something I think a lot of people did, in college or even in high school when you were fitting, a simple line to a bunch of data points, right? So regression is one of the most common types of statistical analyses, and it's a very common technique in machine learning. Classification is right up there with regression in terms of popularity. It is a very, very powerful way of essentially bucketing your data. So creating categories, who's going to pay on time, who's not going to pay on time. Is this going to be a good day to play a sport, a bad day to play a sport? What size clothing should I make for them? Small, medium, large? So that's classification. Those two things that I mentioned, regression and classification, generally fall under the category of supervised learning. Meaning when you train these algorithms, you feed them both the input and the output data, and they learn what that is, and they're able to make predictions. Another really great innovation and a greatest hits along the journey was clustering. And this is when you don't actually know what the relationships are between your data. So for example, you have a social network where people are communicating with each other, but you don't know what groups talk to who about what. And so clustering methods were a way to say, look, I have a bunch of data, but I don't know what categories they fit in. Can you find those categories for me? And that was an incredible innovation, and it was used widely in so many fields. I mentioned social media. It was used by marketing companies. It was used in networking to figure out, which devices are talking to what devices. So that was all just really cool. And clustering worked very well when you had what was called unlabeled data. Whereas classification techniques, regression and classification, so on and so forth, used labeled data, and clustering used unlabeled data. Neural networks could work with everything. So neural networks came along and they were able to kind of make sense with any kind of data, labeled data, unlabeled data, what have you. Neural networks were an important innovation in the sense that they not only were able to work with both kinds, but they were also able to scale to be able to handle a gargantuan amount of data. Whereas even some of these earlier techniques that I mentioned, regression and classification, failed. So we can talk about neural networks some more, but just one thing to keep in mind, you would not be able to build ChatGPT using regression or clustering or classification techniques, right? You needed something as powerful as neural networks to process something as big as language.
So what exactly is this special achievement in artificial intelligence called neural networks? The answer, according to Guarav, can be found by studying our own brains.
So as the term neural network suggests, this was literally mankind's attempt to replicate what happens in our brain. Now, surprisingly, I learned this, as I was researching these topics. Neural networks and the study of neural networks had been around since the 40s and 50s because we'd actually started to understand how the brain worked at that point.
A nerve cell with attached fibers is called a neuron. There are 3 kinds of neurons in the human nervous system. These neurons look different since each kind of neuron has a specialized function.
That was a soundbite from a 1950 16mm film called The Human Body, the Nervous System.
And so your brain and your entire central nervous system is essentially made up of these things called neurons. And neurons are cells in your brain that do a very simple calculation. They take neurotransmitters from other neurons. Neurotransmitters are chemicals. They convert those chemicals into an electrical signal, literally like a voltage that comes out of a battery. And the calculation is very simple. If that voltage meets a threshold, it will propagate that electrical signal to the end of the neuron. And that electrical signal at the end of the neuron gets converted to other neurotransmitters, which get received by other neurons, and the signal propagates in your brain. If that electrical threshold that it assembles does not meet a threshold, it does nothing. It literally does that, and it resets, and it waits for the next set of neurotransmitters to come in. And it's doing this millions of times. There are millions of neurons firing in your brain at any given moment. As you're listening to this talk, as you're seeing things, as you're eating food, as you are going about your day, your neurons are firing all the time. When you're sleeping, your neurons are firing all the time. So this is who you are, and this is what you do. And a neural network mimics that. Instead of neurotransmitted chemicals, it takes, instead of a neuron, it's called a perceptron. That is a node of a neural network. And instead of neurotransmitted chemicals, it inputs in numbers, and it does a mathematical calculation. It does what's known as a weighted sum. And if the end result of that calculation meets a threshold, it'll pass that number downstream in the neural network. If it doesn't meet a threshold, it doesn't do anything. And so that is really what neural networks are at their core. So individual components of neural networks, as sophisticated as these things are, at their core element, they're doing just a very simple summation and a threshold calculation. So that's the heart of what's going on here. So you may be wondering, hey, if the perceptron's that simple, how do you go from like that calculation thing to like ChatGPT, right? Like that seems like a pretty big gap. And yes. And so one neuron in your brain by itself can't do a whole lot, right? But when you combine them together, they can do amazing things. The brain is still, to this day, the most powerful machine learning entity that we know. It is bigger than any language model that we have created, and it works at a power budget that would make NVIDIA, Cisco, all these companies jealous. I mean, it is just a fraction of the power that these language models need to operate at. So really the power comes in connecting the neurons together to make this wonderful thing called the brain. And so with neural networks, the analogy holds. One single perceptron and the calculation that it does by itself doesn't help. So the trick is really, how do you connect these things together? And that's really, there are a lot of analogies in our day-to-day life, right? One single transistor in a microchip by itself doesn't do anything, but you connect a whole bunch of these transistors together into this microchip, and that allows us to do the things that we do every day with computers. Brain, we've used that example. So neural networks are the same way. So the power is in the connection between them and input the data and build essentially a model of the data that you have fed it to be able to make predictions. So the power is in the connections. And I guess us being at a networking company, we would appreciate that, right? We say the power is in the network. Yeah. Yes to all of that. Yes. And the more sophisticated a neural network gets, it's not necessarily because it's bigger. It's also the way we tend to wire things together within a neural network that can make a difference. One great example of a neural network in audio is noise reduction that's in WebEx. And so what the team has done, and they've just done a remarkable job. I'm so proud to talk about this example because it's not just an example of great innovation at work. It had a meaningful impact in my life, and I'll explain that in a minute. What the team did was they basically said, look, let's train a neural network on what actual voice is.
Hello, everyone. Good morning or good afternoon. Thank you so much for joining us today.
What noise is, what lawnmower noise is, what car noise is.
This session will be covering noise suppression compliance part 2.
What dogs barking noise is, and
But before we get started,
all of that. And so what this neural network does after it's been trained is it can take an audio stream, and just like a prism breaks up light into its component colors, this neural network can take an audio stream with the actual voice and all the background junk that's there and essentially break it out like a prism. And now that you know the components in this audio stream, you can literally remove the components that you don't want.
and will also allow you to provide you with a much more timely response. Also, if you experience any audio streaming issues,
And then you reassemble the audio stream into a cleaner stream, and that results in just remarkably clean output. So, if you go to your WebEx and you select optimize for my voice, you have enabled this neural network to start working. And it's gone to the point where I'm apologizing to my colleagues on a call for noises they don't hear. After 7 p.m. in my home, I'm not on a lot of calls after 7 p.m., but after 7 p.m. in my home, when my kids come home, it's just absolute chaos, okay? Like, it's just impossible to find a quiet place to work. But I don't have to worry anymore. When my kids were younger, I would have to take calls from, picking them up from elementary school. Any parent that has been to an elementary school playground knows that is just not a quiet place, even when there isn't recess. So, the point is that if we're promoting hybrid work as really what our future is going to be, then every single place on the planet needs to be an office. And that's not going to be possible unless we have something like noise cancellation. It may seem like something very mundane and boring, but that actually is what makes hybrid work possible. And so that's why it's had a profound impact on my working life, because now I'm confident I can work pretty much anywhere and not have to worry that I'm always apologizing for all the background noise. I don't have to really do that much anymore.
To better understand how these models are working, Guarav talks specifically about how they can detect and recognize patterns in the data you're training the models on.
Here's another example of how the perceptrons in a neural network and how they're connected together can make a difference. So let's say you had a simple picture. Just imagine in your mind a simple picture where you had a cluster of blue dots on a sheet of paper that you've drawn, and surrounding the cluster of blue dots is a halo of orange dots. Now, if you asked any kid, even in elementary school, first grade, saying, hey, just draw a line and draw a boundary that separates the blue dots from the orange dots, they would do it pretty well. Okay, they might slip a little bit, but they'll be able to do it, no problem. Now, can a neural network do that? Well, let's say you had a neural network with just a few perceptrons, let's just say 5. It may not be able to draw that boundary. It just may not, because it may not just be able to really have enough power to do that. But let's say you were able to connect more perceptrons in a neural network, add more layers to the neural network, and do all of that. Then what would happen is that you sort of give it that superpower to draw complicated shapes. Giving it that power then gives it the ability to actually tell the difference between the halo of orange dots and that cluster of blue dots. It's actually able to find that boundary. And again, it just speaks to the fact that single ones of these things by themselves all together are not very powerful if you just have a few, but connecting them together in interesting ways gives you superpowers. Now, the example that I used of the cluster of blue dots and that halo of orange dots, that's a relatively straightforward example. But when you start to get to language, right? Language has patterns that are very, very sophisticated. Or you get to images, and images have patterns that are very sophisticated. Language has patterns that are very sophisticated. That's when the power of neural networks connected, and very large neural networks connected with a lot of perceptrons, that's where it really starts to make a difference. So an important thing to understand about all machine learning, and not just neural networks, is they don't just output a prediction. They output a prediction with a probability. So I'll give you an example. Let's say you build a simple machine learning model using regression to predict house prices. So you gather data from your neighborhood, you make the plot, and you have a model for the housing prices in your neighborhood. Well, a new home comes on the market that the model hasn't seen before, and you want to predict the price of a new home. And it'll say, well, this new home is $100,000. Well, that's the prediction, but there's an error associated with that. And they say, well, it's $100,000 plus or minus $5,000, which is why when you go to Zillow and you see the price of your home on Zillow, it gives you an estimate. But if you look closely, what Zillow is saying is, I'm sure about this plus or minus X thousand dollars. And that is carried over into every algorithm in machine learning. It'll tell you a prediction, but with a probability. So for example, if you showed a machine learning model a picture of, say, for example, a school bus, and there is a person standing next to a school bus, and you said, look, identify what those are. If the school bus and the human being are totally different colors, for example, let's say the school bus is yellow and the human being's clothing is black. There's a contrast there in that image, and it would say, well, I'm confident that this is a school bus, 98%, and I'm confident this is a human being, 95%. But say you gave it an image where the person was wearing clothing that was exactly the color of that yellow school bus. And that person was standing literally next to the school bus, adjacent to it. And you told the neural network, identify what's going on. it may not be as confident. It may say, okay, look, I know that's a school bus for sure, but this blob that's next to the school bus, I don't know that that's a person. I think it's a person, but I'm going to predict it's a person with 65% probability. Now, if you and I were talking as human beings, it would just be silly to say, hey, that's a person with 65% probability. We'll see the man. He's the person that helps the kids get on the school bus. We'll be like, that's a school bus, that's a man. Period, end of story. Like, there's no sort of ambiguity here. But remember, machines need help sometimes. They don't know. And so that's why they make predictions with probabilities. That's what they're born to do. And when we get to talking a little bit more about language models, we'll see that factors very heavily into how language models work and why we can trust them and sometimes we can't trust them.
So let's get back to AI's story. We learned that regression and classification gave way to clustering and then neural networks, which we created based on how our own brains work. By this point, it was the 2010s and the progression of machine learning was actually starting to slow down, but we were still advancing our ability to use machine learning in one area in particular, language prediction.
We talked about the greatest hits of machine learning and AI. We talked about the journey. And so what was happening in the 2010s was machine learning was becoming very popular because it was getting very good at making prediction, right? So we talked about being able to identify things in images. We talked a little bit about predicting, who's going to pay their credit card on time, housing price prediction. They were good at detecting fraudulent credit card transactions. That saved me a bunch of money. It gave me a lot of headache, but it saved me a lot of money because my credit card was able to identify fraudulent transactions based on my spending patterns. But how are these neural networks doing with language? And that's where the story became a little bit mixed and very interesting. So for example, you may have noticed sometime in the past decade, your iPhone or your Android phone, as you were typing, was able to predict the next word or the next set of words. And that's because a type of neural network called a recurrent neural network, RNNs, were starting to get pretty good at predicting one word at a time based on what they were trained on. So they were trained on a lot of text. And so, for example, if you punched into your phone, the quick brown fox jumped over it would predict the next word would be lazy. And then you type in lazy and it would predict the next word is dog because it had seen that in the text it was trained on. And that's a common phrase that you might find. Similarly, language models were very good at things like sentiment analysis. In fact, I learned about this at Cisco. I had learned that our TAC organization was able to feed in text and transcripts from TAC support calls and be able to make predictions like the customer was happy, the customer was not so happy, and so on and so forth. Now, the neural networks didn't learn emotion like humans did. What we had trained these networks on was existing text where we knew the sentiment. So we would feed it a lot of text and say, this sentiment is good sentiment. The text in these passages is bad sentiment. The text in these passages I'm showing you is neutral sentiment. And so when it would see new text that it hadn't seen before, it was able to make a prediction that this is, neutral, happy, sad. Now think about how profound that is, right? We want to know how our customers are doing. And if we see a series of interactions where the sentiment is negative, we can deploy the resources to take care of that customer. That is a very, very profound thing. But again, it's important to understand the machines didn't develop emotions. These are not robots out of an Isaac Asimov novel, right? They don't have feeling. They're just making these predictions. So that was a profound advance in using neural networks for language. They were able to do things like that. They were actually able to do simple things like translation. So if you use Google Translate around 2015, 2016, you could see that it was able to translate one or two sentences at a time in multiple languages, which was really, really great stuff. And, I took advantage of that for sure when I was traveling abroad and needed some help with my Spanish. It was a very handy thing to have on my phone.
But then, the progression and evolution came to a halt. No new capabilities or discoveries were made, and data scientists were struggling to train their models to handle more complex sentences.
Here's where the machines fell short. And this really laid the groundwork for what happened with ChatGPT. The problem was they couldn't handle a lot of text. And the other problem was they would output text sequentially. Now, human beings are very good at that. So for example, if I gave you the following sentence, I'm going to be spending a lot of time in Spain, so I'm going to learn blank. Now, immediately you would think, I'm going to learn Spanish. The next word in that sentence is Spanish. And the machines were very good at that too. So if you gave it short sentences, they would be able to predict the next word. If you left them a blank, they would be able to complete the sentence with that word. No problem when it came to 1 or 2 sentences. But when you gave it a lot of text, they would get confused. So imagine now we were sitting in Las Ramblas in Barcelona, and I was chatting with you, and I was saying, Spain, what a beautiful country. I fell in love with this place the minute I immersed myself in the splendor of this beautiful city of Barcelona. You know what? I think I'm going to stick around for a while. I'm going to learn blank. Now, if you and I were sipping sangrias, you would immediately, before I uttered the last word, you would say, yes, he's going to say, I'm going to learn Spanish. But the machines would get completely confused because in that sentence, the word Spain came at the beginning, and there was my whole sort of love affair with Spain that I put in the middle. I didn't mention the word Spain. And then I asked it to predict the word, but the word Spain was so far away in the conversation that it sort of lost track of it. And so again, humans are very good at context. You know I'm talking about Spain. Gosh, we're sitting there sipping sangrias for the love of God, right? So of course the word is Spanish of the language I want to learn, but the machines couldn't do that. And that is where we got stuck, and we were stuck for a while. The bottom line is 1 or 2 sentences, no problem with prediction, translation. When it came to paragraphs, completely fell apart. In fact, they wouldn't even make any sense. The next word they would predict wouldn't even be Spanish. It could be hypervisor. Who knew? Like, it was just complete nonsense when you gave it a lot of text. And that was really the problem statement of 2017. So when I got into this business in 2017, this is where I found it. Now, I wasn't advanced enough in my studying at the time to know the nuances of this problem, but my mentors, the people who were teaching me on data science, this is what we were talking about. We were eating in the cafeteria. We were not sipping sangrias in Barcelona, but this is what we were talking about is, hey, we don't have a good way to handle a lot of language. And that kind of caused roadblocks with projects in Cisco where there was a lot of text that we needed to process. We simply didn't have good ways of doing that, let's say mid-2017.
But then later that year in 2017, a paper was published about attention that pushed things forward.
So in December of 2017, if you happen to be in Long Beach, California at a data science conference, by the way, I love Long Beach, California. I'm there in a lot of Decembers, and I will be this December. Go to the beach, go to the pier, get ice cream, have fun. Don't go to a data science conference. But if you happen to be there in December of 2017, you are in for a treat because a group from Google presented a paper called Attention is All You Need. And Attention is All You Need was that breakthrough moment. It gave everybody a roadmap of how to break free from the chains of only being able to work with small amounts of text. It introduced this mechanism called attention. Now, attention wasn't completely new, but the way the Google team presented it and how they had constructed it was so remarkable, unlike anything that we've done. And they gave us a roadmap to say, okay, when you have a lot of text, this is how you should go about processing it. And here's how you can understand and train machines on text so that you give it the context that humans do so naturally, but now the machines can have that ability too. That was the real breakthrough at the end of 2017. And starting in 2018, that just set off a Cambrian explosion of people working on this. I mean, basically, if you were working in AI and natural language processing, which is what we used to call generative AI in the old days, if you were working in this field, I mean, you knew what you had to do, right? Like, it was just like, boom, like, I got to go there. And that led to an incredible amount of work in the next, I would say 4 years that really set the stage for GPT. So the Attention is All You Need paper is remarkable in the following way. And if I can use an example, let's say I gave you the sentence, I swam across the river to get to the other bank. Now, immediately, you've been doing this since you were 2 years old, okay? You know that bank in that sentence doesn't mean Wells Fargo, Bank of America, or a place where you put your money. It means riverbank. But the machines need help. And so what was remarkable about the attention mechanism is that it gave the machine an ability to connect the strengths between the words. So what it would do is it would say, okay, in this sentence, the words swam and river are very important when you're considering the word bank. And so the relationship between the different words in a sentence have now a mathematical connection. So river, swam, and bank have a higher number, let's say, connecting them, than say river and the. Literally, the word attention means where do you want to focus your attention when you're predicting words? And the attention mechanism gave the machine a mathematical way to say, consider these things as more important and the other stuff is noise, which is actually what your brain is doing in a much more sophisticated way. So it gave the machine the ability to use context when it predicted the next word. What we'll get to in a minute is that prediction still comes with a probability, but the important thing to take away is the attention mechanism was that roadmap. It was that roadmap to giving context to language to machines, which was missing in the simple examples we used before about the iPhone next word prediction or the sentiment analysis. So I mentioned the attention mechanism. That was one really cool scientific thing in that paper. There were other things like, for example, positional encoding. So when you have hundreds and thousands of pages of text, how do you keep track of where words are? You can't say 1, 2, 3, 4, 5 position, all of a sudden that becomes very kludgy. So there was this concept called positional encoding that was also really cool science. So that was part of the puzzle. The other part of the puzzle is we were able to train these things on just unimaginable amounts of data from before. So for example, ChatGPT, just to use that example, the same would be true of Llama and Anthropic's model, Claude, and all of these.
The two models that Guarav just mentioned are Llama from Meta and Claude from Anthropic. Llama stands for Large Language Model Meta AI and is a family of large language models released by Meta AI starting in February 2023. Claude is also a family of large language models developed by Anthropic also in 2023.
Is they're trained on these enormous data sets like all of Common Crawl. So Common Crawl is like a snapshot of the internet. GitHub, they're trained on Wikipedia and this huge corpora of books. So just massive, massive amounts of text. And the third thing is they're just really big. When I started, if you told me there was a neural network of like 1 million parameters or 10, 15 million parameters, my first question back to you would be, man, where are you storing this thing? That's a lot. ChatGPT 3.5 is 175 billion parameters. The rumor is GPT-4 is 1 trillion parameters. They haven't told us. They're keeping their cards close to their chest. But people believe that it's 1 trillion parameters. I mean, that is just enormous. But again, the scale is, remember we said neural networks, one of the reasons they became so popular is they're able to handle a sheer scale of data that's just not possible with classification, regression, and clustering. And so that is what these neural networks have gone so big, is because the scale of what they're ingesting is so massive. It is literally language. You can just imagine the amount of words that are in, just your local library, much less the Library of Congress, and so on and so forth. So really, it was the scale of the models, their physical size, the corpora that they're being trained on, and some really cool science. The combination of these three things is the magic that we have today.
As you can tell, there is so much to know about generative AI. But just to make sure that you've got the foundational knowledge down, it's important to understand the distinction between generative AI and predictive AI, or some of the more traditional methods.
Now, let me just add a little comment here. I don't love the term traditional AI because when you hear the word traditional, you think it's old school. I want to be very clear. Some of these traditional AI techniques like regression, classification, clustering are very powerful. They're still used today, and they're used extensively in Cisco products and products from our competitors. So they ain't going nowhere, okay? They are very powerful. It's just we call them traditional because they just came first. So traditional methods, so what we call predictive AI or predictive methods, are, as the name suggests, they make a prediction. So predict for me who's going to pay their credit card on time, predict for me this housing price, predict for me whether these cells from this tissue are malignant or benign, right? That is what predictive algorithms do. Generative AI is distinguished from that because it generates words. So as opposed to just making a prediction and telling you that prediction with a probability, it's actually generating words. But here's the connection between these two worlds. So yes, that is how they're different on the surface. Here's how they're similar under the hood. As ChatGPT is predicting words, it's actually, before it gives you a word, under the hood, it's considering a bunch of different words with different probabilities. So what you see is the final word that it's selected, But prior to that, there's just one very important step, which is it's got a bunch of words that it predicted could come next. It just picks one, and you can tell it to pick the word with the highest probability. So there is actually kind of a connection between the two worlds, but on the surface, let's make that distinction. Predictive AI, you're making a prediction about some category or some number with a probability. With generative AI, you're generating words, text, passages, images, and so on and so forth. But under the hood, what unites these two worlds is the fact that they're all probabilistic systems. So let's take predictive AI. You can use predictive AI to do a lot of things, like, for example, recommend a better path for your traffic. We use a lot of predictive AI techniques in our Catalyst Assurance product to not only understand where something went wrong, but to actually do some root cause analysis. That, we can build very dynamic baselines of what your traffic for your own particular network is. And when you have deviations from that traffic envelope, it can flag that something went wrong. Well, that traffic envelope is created using predictive AI techniques to say, okay, look, for your specific network, for this particular customer, here's our prediction for what the flow would look like. I mean, these are very, very powerful ways to use them in networking predictive. On the generative AI side, there's so much exciting stuff going on because now you can have these intelligent assistants that help you configure a network. So yes, we still want people to pass their CCNA. Yes, we still want people to know what BGP is. Yes, we still want people to understand access lists for firewalls. But you can imagine that not everybody has that need or wants something simpler. And so they can get to a security assistant, for example, and say, show me all the duplicate rules that are in my firewalls. Well, the firewall has not learned to speak English. But remember, the language model is very good at translation. So it can translate from English to Spanish. But what it can also do is translate from English to firewall policies and configuration commands. And so it's doing that translation. The firewall is not even aware that you're using an assistant. It sees a command, it executes that command, and then the language model takes the output of that command, the log files, and converts it back to English. So there's a lot of exciting stuff going on with both predictive and traditional techniques and also generative AI techniques that you're going to see completely infuse every single product that we make. This is such an exciting time to be at Cisco because, the transformative power of AI, we're going to see everywhere. There is no product that doesn't have AI in there. Let me put it another way. Every single product, every single platform has AI somewhere in its roadmap. And boy, is that exciting. And really looking forward to a lot of that stuff coming to fruition. Here's the thing. If you're wondering, hey, how do I get started? Look, don't make it complicated on yourself. Don't go take a math class. Don't go learn a whole bunch of math and coding like I had to do. Just go play with ChatGPT. Just understand how it works. Understand how you prompt it. Understand the usage of it. Use it to train yourself on things. Just become very proximate with the technology because, first of all, you're not going to break anything. Secondly, you're going to learn how this thing that's now going to be with us for the rest of our lives, how does it really work? So my just very strong advice to all of you is just learn it, enjoy it, have fun with it. You can dive in deeper. There are a lot of resources to teach you about AI, but don't be intimidated and just get started with it. You're going to have a lot of fun. And like I said, it's just a very exciting time to be in this field. I'm loving it. I'm just having a great time exploring myself. I'm as much of a student as I am a practitioner of this technology, and I love talking to customers about it. So let's have some fun.
That's it for our episode about generative AI featuring solutions engineer leader Guarav Khanna. If you'd like to learn more about the AI updates to the Cisco certifications exam topics lists and about how AI pertains to network operations, please visit the Cisco Learning Network at learningnetwork.cisco.com. There, you can find all kinds of resources like study guides, training videos, exam topics, and an entire community that can help you in your learning journey. And please subscribe to the Cisco Learning Network podcast to hear more news about Cisco's certification portfolio and stories from others who are on their certification paths. Thanks for listening.